Hello everyone! We are going to be doing some more Algebra 1 today, and we're going to be solving more equations. Something I do every day in my job is solve equations. Some of them are very complex, some of them are very simple, and some of them are somewhere in between. So if you go into a science field, I think this is super useful. It is going to be used quite a bit in any kind of science field. So I hope you pay attention. So today we have one goal and one goal only, and that is to solve equations by using multiplication and division. That's our only goal the entire day. Alright, so let's go ahead and dive on in. Let's look at a property. Like we did last time, we had two properties, and today we're going to cover a couple more properties. So today we're going to talk about the multiplication property of equality. Equality. Alright, so this is going to be very similar to what we talked about before. We're just going to replace the words addition and subtraction with multiplication. Alright, if each side of an equation is multiplied by the same number, the resulting equation is true. Alright, so what do we mean when we say sides? Like you take sides, what is this? So when we have an equal sign, we have some stuff over here, blah, 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 and we have stuff over here, blah, blah, blah. So we're talking about each side. We have the left side and the right side. Where did my line go? Okay, so this is what we are talking about, the left side and the right side. So let's take a look at this numerically, what this definition means. Let's say we have 3. A 3 that we can read. 3 is equal to 3. This is a true statement. Let's say I just want to multiply this 3 by a number. So 3 times 7, we got to do that on the other side. 3 times 7. Well, 3 times 7 is not 30 something, it's 21. And 3 times 7 is 21. Those are the same thing, so it's still true. So that's what this property is saying in layman's terms. Alright, let's look at some examples. We have our first example of the day. Let's say we have x over 3. That is equal to 1 over 10. This is interesting. So what do we need to do to get x all by itself here? Well, x right now is multiplied by 1/3. So what is the inverse of 1/3? That's 3 over 1, or just 3. So what we have to do then is multiply each side by 3. So we have 3 times x over 3 is equal to 3 times 1 over 10. Okay? So when we do that, these two cancel. Okay? And then we're just left with x is equal to 3 over 10. Not bad, huh? Alright, let's check this. We want to check this and make sure that it doesn't bounce. And you may not get that joke. If you don't, ask your parents. So let's plug in 3 over 10 here for x. So we have 3 over 10. And this was originally over 3, which is the same as 3 over 1. Okay? And then this is equal to 1 over 10. Okay? Well, we know that when we divide one fraction by the other, this is the same as 3 over 10 times, and we had to flip these two here, 1 over 3, that's equal to 1 over 10. So that gives us that 3 over 30 is equal to 1 over 10, and we know that this reduces to 1 over 10. Because 3 times 1 is 3, 3 times 10 is 10. 3 times 10 is 30. So 1 over 10 equals 1 over 10. We checked out. Alright, let's look at another example. Again, any point in time, you need to pause and rewatch. Do so. Alright, example 2. Let's say that we have 1 3/7 times y. And that's equal to 1 1/3. Okay. So what are we going to do here? Well, let's make this a little simpler and put this into improper fraction form. So let's say we have 10 over 7 times y is equal to 4 over 3. Okay? Alright, now, how do we get rid of this 10 over 7? Well, I think if we multiply that by 7 over 10, then do the same thing on this side, then this all becomes 1, and you're just left with y. 1y is y. So y is equal to 28 over 30, which is equal to 14 over 15. Alright, let's do a check. Let's look at plugging in this into y. Okay? So when we did the improper fraction, we had 10 over 7, and if we plug it in for y, it's 14 over 15. And then this was equal to 4 over 3. Okay? So 10 times 14 is 140. 7 times 15 is 105. This is equal to 4/3. So I know that I can divide 35 into this number and this number evenly. So if I divide 35 into 140, I get 4. If I divide 35 into 105, I get 3. That's equal to 4/3. Ta-da! Woohoo! Look at us go. Alright, let's look at another example here. Example 3. We are moving right along here. Let's say that we have 1 minus 3. No, that's not what we have. We have 1 is equal to minus 3z. Okay? Well, what we can do is divide each side by minus 3. What does that give us? That gives us that minus 1 over 3 is equal to z, because z's go to 1. And then 1 divided by negative 3 is minus 1/3. Great job. Alright, let's look at another example here. Example 4. Let's say that 1/6 times the weight on Earth equals the weight on the moon. Okay? And the weight of an astronaut's suit and life support backpacks on the moon is 33 pound, and the material that I'm working from here didn't really give this much detail, and I feel like it's necessary. They did not give these units, and I want to say pound force here, okay? And you may not understand what that means, and that's totally fine, but in my line of work, this is very essential to know. So we will have a question here. What was the weight on Earth? Great question. Great question. So, before we answer this, I kind of want to explain something, why you have different weight on Earth than the moon. So, you have this thing called gravity. Okay, anybody ever tell you that the Earth sucks? Well, it's true. It brings everything down to it. And the moon does the same thing. But they each have a different pull. And this pull is called gravity. Okay? And this is an acceleration. And you may not know what that is, and that's okay. But I just want to explain this to you because this is very fundamental to the work that I do. And the way that we come up with weight, we take mass times gravity. Okay, this is basically derived from the force that F, which is force, is equal to mass times acceleration. And this is a very, very famous equation here. And so, you don't have to understand all this, but what changes here is that the mass of the backpacks does not change. The only thing is changing is this. Okay, the acceleration and the force, which is the weight. Okay, this part here remains constant. The mass remains constant. So we're given, in this case, that 1/6 of the weight is equal to 33 pounds. And I'm going to say force to designate the difference between force and mass. Because weight is a force. Alright, so if we solve this, we multiply 6 times each side. We find that W is equal to 198 pound force. Okay, so it's a lot heavier, a greater force here on Earth than it is on the moon, because the Earth sucks more than the moon. It has a larger gravity, a larger acceleration than the moon does towards the center of the Earth or moon. Okay, let's move on, because y'all probably don't need to know all that, but this is just something fascinating by me. Let's talk about another property. We have the division property of equality. So backing up, if you want to know more about that equation and how that works, I can do something on the side to explain that. But just let me know in the comments field if you want to know anything more, or if you just have a question. I'll be glad to answer it. Alright, so what is this property? Basically the same as the last three, except we're going to say divided by. So if each side of an equation is divided by the same non-zero number, this is key, non-zero, the resulting equation is true. Now, the other things that we mentioned, we never mentioned that it had to be non-zero. That's the one thing that's different than the other three properties. Because if we add 0, you're going to get the same thing. If we subtract 0, we're going to get the same thing. If you multiply by 0, you're going to get the same thing. But if you divide by 0, this gets a little complex in the world of math. But we'll leave it there. So let's look at an equation here. We have 12 is equal to 12. Okay? So let's divide 12 by 3. So divide by 12 by 3, we get 4 is equal to 4. Same. Alright, let's look at some examples. Wow, we're on example 5. Look at us. We want to solve 3x is equal to 1. Okay? So what we're going to do is divide each side by 3. So then that gives us x is equal to 1/3. Wow. We got it. That was an easy problem. Let's take a look at another one. Let's look at example 6. We can't even read what that says. Okay. We want to solve minus 7y is equal to 28. So let's divide each side by minus 7. Okay, if we do that, minus 7 divided by minus 7 is just 1. So we get y is equal to 28 divided by minus 7, which is minus 4. Because 1 is positive, 1 is negative. Alright, let's look at one last example and we will call it a day. We want to write an equation for the problem below. Then solve the equation. Alright, so what is it? We have negative, I don't know if you can tell what some of these letters are. And we lost the place again. There we go. Alright, we're back. Negative 1 times a number equals negative 3. Alright, so let's solve this. We got negative 1 times a number. Well, we get to choose what that number is because we don't know what it is. We'll just choose y. Equals negative 3. Alright, so we did the first part. We wrote an equation for that problem. Now we have to solve the equation. What are we solving for? Y. So let's divide each side by negative 1. So we find that y is equal to 3. Great job. Alright, I will see you all next time. Please like and subscribe if you haven't already.